Hello and welcome back to the Google APIs for Rust and YouTube Uploader Development Stream. It's Byron speaking, and we are back with our mission to finally get rid of this blocking issue here by writing a filter system that allows us to easily implement filters working on lexical tokens of a JSON data stream. Sounds as simple as it is because we're kind of on our way to implementing this. I, for a moment, was wondering if I wanted to duplicate that because we could, I think, kind of deduplicate that a lot. All this stuff here. I mean, a bit, but for now I feel lazy and just copy pasting this boilerplate here seems adequate. Also, this allows us to have like multiple different names for each of the tests, which kind of helps when we see running these. So yeah, let's do this, or let's keep it. In the meanwhile, while having dinner, basically, I updated Travis cargo configuration and the Travis configuration. So we now have the configuration of the documentation of json-tools online here, and it will automatically be updated every time you push, which is quite nice, I think. Unfortunately, it doesn't yet work in beta. Or actually it does work in beta, but not in alpha or something. Nightlies, which is fine. But yeah, that's how we do that, and it's pretty good. So it has moved forward a tiny bit. Build is passing. Yay. Finally. Well, finally. I also figured out what the problem was with the documentation not being uploaded. It's an after script that doesn't trigger failure if it fails. And it was actually looking for a GH token environment variable that contains the unencrypted GitHub token to use for uploading stuff under my name. All right, so the next thing shall be what's left. Booleans. We have string value, we have null value. Let's do Boolean true and false. Yeah, that's kind of an annoying one, because it's like 2 times what we have here with our buffer already. True and false. We could even use this for buffer. This is for TRUE FALSE. So we have a 4 buffer and a 5 buffer. So how often do we use it? Not too often. I think it matched pretty well. So B4, it's called a 4 buff. And a 5 buff. So we can use the 4 buff for true, and then we kind of use different indices here to keep track of the stuff. And for indexing, we need a usize, so I keep it all at usize, even though obviously we don't need to have such a high value here, or such a big double word integer here. But anyway, so B4 is a null buffer. Is a buffer for 4 characters. And B5 is a buffer for, you guessed it, 5 characters. Yeah, and so I'm really looking forward. There's still some work to do to get it all done, but I think later today it will actually be done. It will take a while, probably until, well, 11-ish latest, I hope. Because once I have this filter, I think it's super easy to integrate into pretty much everything else, and then it's just a matter of minutes until you know if it works or not, and it's gonna be integrated into the output so that our tools finally generate the output they want to generate, and obviously so the CLI will benefit from it, as well as the server side that will only send stripped values. I might even strip white space from it. Yeah. Yeah. I'm thinking Yeah, no, I was getting ahead of myself actually. Copy paste error. I was thinking about this machinery that I want to have for the token stream filtering, and I think I've got it. But anyway, so here we go. Now it's more like being super stupid. First, T is our character for true, and F is our character for false. Right. I think so. Yeah, so let's do it. We are lucky that there's no double duty here, so that we have to kind of peek into the future until we can make the decision for that. That's very, very nice. True, false, ftn for null. And that's it. Yeah, looks good. So let's do it. So what's coming first? I think we should first, I don't know if order makes a difference, but I guess what happens more often in such a stream is this. This is kind of these brackets are a common case. Then this, maybe this already alters the performance characteristics. I don't know, probably not. And this is kind of a special case. This comes last. Yeah, I'm wondering, does it alter the performance characteristic? No, it doesn't. Sometimes it just does a few runs, sometimes it does many runs. I don't know. But it doesn't matter, so that doesn't change much. But I think that's kind of in order of, and that's what I wanted, in order of priority, because that character falls through there. Bing, 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 bing. This also means, so in prioritized order, where does a true or false come? Probably kind of more often than null values, because most people don't send them. So let's put it right in front or right underneath these characters here. Oh yeah, but maybe it can actually be here and then underneath that. That's kind of more like it, maybe. So we have true. Let mut true buffer index be usize 0. True buffer index. Let mut false buffer index be usize. We don't have to parse it, but we do it anyway. Go the extra mile for fun and fame. False buffer index. And that's kind of the same thing. Debugger assert is really the same thing. We just change a few values around. So be careful. True buffer index should be 0. True is the before. 0 is C. TBI is then 1. We set the cursor. We're good. Then the same thing goes, for F. Which is the F buffer index. That's B5. FBI is now 1, and we go ahead. So now we are in either of these modes, then first string, then null check, then elif, else if. True buffer index is greater than 0, else if false buffer index is greater than 0. And for these, I kind of feel more like I want to have a test case, because that's kind of double the work. Maybe for the null stuff as well, because it's really, really similar. Unescapable, these values here I think I am putting all these together into one. That's making sense. That will save time. But one step after another. First I implement it, then I refactor, and yeah. So then, this is a true one. Null fast path, true fast path, false. Fast path. Now, very, very careful here. Good thing is everything here is already implemented. Before TBI is C, if TBI is at the end of the known thing, we know before 0 is a T, so this is an R, U, E, boolean true, and very good. So if this is not the case, remember, then we will remain invalid as a token type, but still break, still abort. We tried, that's how that goes. We try to parse a true once we see the T. And we can do that because we are lucky bastards. Totally. And here, not to forget, TBI should be incremented so that the next one coming will go into the right slot. False path, same thing, but different. Now replace everything with B5. B5, false buffer index. The false buffer index is 4 because we have one character more. Now we know that B5 0 is F. B5 1 is A. B5 2 is L. B5 3 is S. And B5 4 is E. False. That's boolean false. And we're done. And then we have false buffer index plus equals 1. So that should still work as before. And it does. Benching, probably slower now. Like lots slower. Well, a bit slower, but not too much. But hey, we can parse more now. That's how it is. Every token we parse costs us time. Because of our state checking here. And yeah, if you could peek, this would be, I think this would be better, possibly, I don't know. And this will get even slower because we have to start keeping track of the characters we see in some buffer to make it easier later to regenerate byte streams from, or character streams from the tokens, which is what we want in the end, right? So that's where it will lose even more. But it doesn't matter. We are still really, really fast. Snappy, one could say. And yeah. Right now, I also don't know how to make it faster, to be honest, because I think this is already decent. But if anybody's hearing this, you don't think it's decent, then please show me what could be done using commonly known parser technology. All right. Now the simplification. Implementation was a matter of like 10 minutes or so. Now the simplification. So I use just this thing here. Yeah, special values. Closed and unclosed. Oops, like that. Okay, so we have a nested structure, that's for sure. I think I want to have source and then skip. I always skip. I think it's always 3. It is always 3 the way we do it, so we don't need to do a skip pass. Then we want to have the kind first and end. Those kind of the tokens that we have in. Oh, and possibly I will have to ref all of them, huh? That's a ref already. I might have to ref a few things here. Unless I ref this. I think that now I feel better about this. And we have a list of tuples and 1 per line. So let's start with this one. So that's the source. Kind is token type null value. And then we have 5 and 9. So that should already, if I would get the thing right, should already be good. Does it compile? Maybe like this. Yeah. Sorry. Slices, please. Do I have to ref all or just ref this? Or is that truly invalid syntax? Truly invalid syntax. Yeah, then I have to ref all of these, sure. Wait, not this one. This one. Good. And now I can just get the new lexer here. I don't think it has to be mute. Actually, I can just put it all in line here. Assert equal lexer new, and then we don't go by ref anymore because we only have 1 item. Oh no, we need to skip it, right? No, actually, we can. No, we need to do by ref. Because otherwise, after the. Let me check that. By ref, yes or no? I think yes. No. Not in this context. It consumes the iterator, but yeah. So we don't. Skip is hard-coded 2, skip 3. Next. That's exactly what we want. Then we set up the token for comparison. Here. Yeah, I might want to. Maybe I don't have to give it more space because our kind is very cool. It actually looks good. I am very amazed. So first and end. Nearly. It might still work out fine. See? Lucky. Not anymore. Ha. Very, very close though. Let's put it 1 down though. Like this, and now we are done. So that should do it, right? That's the null. Oh yeah, you have to put it in. All right. It's not copyable, and it's also not clonable yet. Let's implement clone for these guys. Why not? Makes it more useful. There we go. And now it doesn't need to be derefed anymore because the clone will do the job. Voila. And this mutable stuff will be fixed in the process. Cool, here we go. That's the thing, and now all we have to do is add more test cases. This goes away. Now it's that one. That's the unclosed one. Hope they all kind of fit the line. Token type null value 5.9. Oh, sorry, it's invalid then. Yeah. Looks good. Let's see if it works. It does. Nice. Cool. And now it's about adding the true and false cases. Let's do the true one first. True closed. I can copy this. And then we have the cases. That's pretty cool. And we have implemented that already. So that's going to be an awesome true. Let's call this v now for value. Not that it would matter at all, but I don't want to start changing this all the time. So here we go, true. That's a valid true value. And it should have boolean true. And it should have the same. Yeah, I might want to adjust these as well. String value, boolean true value. Value, I might, value string, value boolean true, value boolean false. Right now I'm kind of all over the place with my naming here. That sucks. Yeah, let's not do this. Let's do it right away. So we chose to do classification by the type, kind of. So we have to do value. Just curly brace, we would have brace, curly, open, brace, curly, close. Well, maybe I leave the brace out of the equation because that's kind of very, very arbitrary. String, let's call it string, boolean true, boolean. Let's just cut the value there. Let's keep it short and spicy. RS. Then I don't have to change so much to no. Yay. Awesome. So here we go with boolean true. Does it work? Let's try it one after another. Voila. It did work. Now the false one, I'll start off at this guy. Actually, why would I? I can start off at this guy. All I have to do is change one character. Put this to invalid and call this trucks. Haha, trucks. And it works. Okay, now I copy everything. The more you copy paste, the worse. So this is false now, boolean false, one character more, one character more. And the bad thing is that we will also, in this parsing mode, we will always kind of parse, we will even parse valid characters, So if I would just remove a character, so that's false, or like this, then all of a sudden I would try to parse this as part of the false. It will still be invalid, but then a lexical token is completely missing. So I think that's the shitty part. And this is where the previous implementation was actually kind of better, but this would also make the lexer more complicated. So I say F it, and we do it like this. So that's an invalid token of the same size. Should still work as before. Yeah, it does. And just to be sure, let's make it too long so the span doesn't work anymore. Okay, but still, it's makes sense. Can make it longer because it will stop parsing after exactly this many characters. And that's it. Cool. So we verify that we can sufficiently well parse this. If not, if you want to have special cases, we can add this later as well. Cool. So that's true value parsing. Next one on the list is number parsing. Then we are already done. Feed lexer. True and false value lexing, including tests for both. Refactored test case for null value 2 easily test booleans as well. Nice. That is that. I think we never tested a comma yet, and certain other characters. But yeah, that shouldn't matter. In the moment I test the streaming and so on, I believe that we will have like real hardcore evil matching tests that check it down to the individual byte, because that can't be wrong. This must be working. And we might even try to sneak in streams that cause invalid ones, just to be sure we can handle these. Accordingly. Like that. Huh. Okay, cool. So I guess it's getting tired time slowly. I'm losing energy because I've been standing here the entire day, and still not time for relaxation. Because things have to happen. I want this to work, whatever it takes. So let's do this. Thanks for watching and have a good day.